Hello. If my voice is clear, tell me in the comment section. Hello, hello. Hello.
Hello.
Fine. Namaskar, Adab, Sat Sri Akal. I hope that all of you are doing very good. So finally, now we are at the verge of completing this chapter wave optics. From last 4 to 5 lectures, we are only studying about wave optics, and now we are into the final section, very small section, but yet important, I will say, because it is a very easy topic. Polarization that I am talking about, we have completely seen YDSA. YDSA was the most majority weightage topic that I will say from wave optics. So you cannot let go YDSA firstly. Then diffraction, I've told you that from where mostly the questions will be coming from the minimum formula. If you are remembering that sin theta is equal to n lambda by a, that is a general formula. If you are remembering that will be more than sufficient. Now after that, what will be coming after that? This topic polarization, very small topic, but probability is there that sometime question have been asked from this topic also. Okay, so that will be polarization. Let's understand now what is polarization. So for polarization, what is polarization? If I will tell you, before that you have to understand what is the behavior of light. Light is also a kind of electromagnetic wave. Okay, so let's suppose in electromagnetic wave, I have told you that when our electromagnetic wave is propagating, let's suppose it is propagating towards you, electric field and magnetic field will be oscillating, and these oscillations will be in perpendicular direction to the propagation of wave. Perpendicular direction to the propagation of wave, that means in the plane of wave. For example, let's suppose towards you, this the pen is showing this pen is showing that wave is coming towards you. All light have the same property as electromagnetic wave. So let's suppose this light is coming towards you. So what will be happening? Electric field will be oscillating in this direction, in perpendicular direction, in the plane. It is in the plane of the paper and perpendicular to the direction of propagation of wave. This is the natural behavior of electromagnetic wave, and same way for magnetic field also. So this, for example, let's suppose here this electromagnetic wave is propagating in the positive direction, and this is the representation for electric field. This blue line, blue oscillations, is representing electric field line that is oscillating in perpendicular direction, and that is in y direction, and magnetic field is oscillating in z direction, represented by orange color. Okay, so this is the oscillation that is represented. So here, see, what is unpolarized light? Unpolarized light, firstly you have to understand some basic definitions. The vibrations of field occur symmetrically in all the directions in plane perpendicular direction of the propagation of wave. If your oscillations like electric field oscillation and magnetic field are oscillating, if that oscillation is happening in all the directions, it means in this direction also, 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 in all the directions that is perpendicular to the direction of propagation, that means in the plane of paper, just I was showing you in the plane of paper, then it is called as unpolarized light. From this definition itself, it is very clear that what is polarized light. Polarized light means what? If the vibrations of electric field is only in single, it is restricted into single direction. Single direction means what? It is still oscillating perpendicular. Let's suppose it is oscillating in this direction. If it is restricted to only one direction, perpendicular to the plane still, but restricted in only one direction, that kind of light is called as what? Polarized light. And the process or the phenomena of converting this unpolarized light to polarized light is called as polarization. Now we have different kind of methods. Like in it is mentioned by using some crystals are there, tourmaline crystal, nickel prism, these things are also used. Then we use reflection also used to Brewster's angle, we'll see. So these are the methods from where by using polarizers also we are going to see the polarizers. So these are the methods which you can study from NCERT. Much better content or theory part is available there, so read it out from there. So all these things will be doing what? These are the polarization that will be helping you. Now let's understand how practically it is looking like. See, here it is represented that it is electric field is oscillating in all the direction. It is the plane perpendicular to the field. Now when you are converting this into a single directions, then it will be called as polarization. This is the example for unpolarized light. Okay, see, how do we get unpolarized light? All the sources, let's suppose bulb having, candle, sun is also giving you unpolarized light. light source is there, vibrations of electric field, it is shown here. See, light is going in this direction and vibration on a plane of it is drawn here, and you can see that electric field is oscillating in all the directions perpendicular to the direction of wave propagating, but it is vibrating in all the directions. If you go to any shop where you can purchase specs, lens cart or something, they will when you are taking the sunglasses, they will ask that they will tell you about a property, sir. This is a polarized, this is the polaroid glasses are used. Okay, so what is the meaning? Actually, the sun light that is coming is unpolarized light, and what that kind of special glasses do, they decreases the intensity. How much they decrease, that is the different case. We are going to see that. So that's why also this is the behavior of the sunglasses. If the ability of your sunglasses to polarize more of the light, it will be much better for you. Okay, so this is the property that you will be observing there also. Even in chemistry also, in stereochemistry, if I am not wrong, asked to Suhas, if I'm not wrong, stereochemistry also, a lot of places you study about polarized lights, correct? PPL is the representation, I think so, if I'm not wrong. Okay, so all these are the examples of polarized light. It can vibrating in any direction. Now see here, what is polarized light? See, here is a light bulb glowing and it is passing from a polarizer. Not it is just a plain paper where it is represented how it is oscillating. So here it is represented very beautifully that it is oscillating in all the directions. It is oscillating in all the directions. Then it is passed through a polarizer. Here it is called as polarizer, and if you will properly notice, polarizer is having some straight single lines. It is having some this kind of lines. So whatever the component of this unpolarized light are passing from this polarizer, these let's suppose if it is this amplitude will getting passed. That means it will restrict the rest of the directions. It will only allow, this polarizer have the property that it will only allow the parallel oscillations that are happening in the light to pass through it, and rest of the things it will restrict down, and after that we will be getting the, obviously it will be the polarized light. And how we represent, see here it is vibrating in all the directions, and after polarization it is vibrating in only single direction. So it will be vibrating in the perpendicular direction to the propagation of wave, but it will be vibrating in the oscillations will be restricted in only one direction, not all the directions. Clear? This is the understanding of polarized light. Okay, what happened? Plane polarization. Now what is plane polarization? The vibration of electric field occur only in one direction in a plane perpendicular to the direction of propagation of light. This is the definition for plane polarized light. And plane of polarization, the plane in which it is getting oscillation, that is called as plane of polarization. Lot of definition, theoretical things are there that you have to understand. See, and how we get polarized light? Firstly, using a polarizer. And I've told you what is polarization. Polarization is a phenomena of restricting the oscillations of electric field in a single direction, that is called as polarization. Simply, here it is representation for unpolarized light. Here it is looking like that you will be thinking, sir, it is also polarized light, only vibrating. No, this dot is there. This dot is representing that it is oscillating in all the directions. This is unpolarized light that is passing. Now I have taken a polarizer, and then after it is, see here there is no dot. That means it is a single direction. Now it is allowed to transmit after the polarization. That means now we got a polarized light. Okay, simply this is the method using a polarizer. So now we will understand about Malus law. Malus was a scientist who have given his theory on polarization. What was the theory that he have given? He have said, after passing, we majorly talk about intensity of light in polarization, and he have given a theory that intensity after polarization is equals to I naught cos square theta. It is equals to I naught cos square theta. Now what is the meaning? Let's understand. See, let's suppose this is a polarized light. Okay, a polarized light is coming. Okay, polarized light, let's suppose intensity is I naught. Intensity is what? I naught. So here what I can say, if I am at the amplitude, these are the amplitudes. So let's suppose amplitude is A naught. Let's suppose amplitude is A naught. So what I can say here, you know the relation between intensity and amplitude, that intensity is directly proportional to amplitude square. Correct? All of us know about this relation. So I can say I can write some K A naught square. Correct? Correct. Now see, some plane polarized light was coming and the polarizer is at some angle theta. If the polarizer is at some angle theta, can I say this is the actual light that is coming and this is the at this polarizer at some angle theta? That means what is the angle between them? I can say theta. So can I say the component of this amplitude will be passing through here? That is what, which component of the amplitude will be passing? If this is a, this angle is theta, can I say the amplitude that is passing is a cos of theta? The amplitude, these amplitudes that are given here will be passing, in general I am talking about, in general it will be how much? A cos of theta. So what I can say here, after passing from a intensity, let's suppose here intensity is I naught, this is I naught. So here what I will say, again intensity is directly proportional to a square, and what is the amplitude here? It is a square cos square theta, correct? So what I can say here, when again I will remove some proportionality, what I will have, I will write intensity is equals to ka square cos square theta. And what I can say about ka square, beta? K square or a naught, you can take a naught as if you are taking here a naught, you can take it here. So can I say this is what k a naught square? Already you have defined k a naught square is equals to I naught. So I can say finally I is equals to I naught cos square theta. Can I say I is equals to I naught cos square theta? Correct? Is it clear? And most of the time we take it as when we take the average after passing from here, let's suppose if intensity is I naught here, after passing from here, the intensity, average intensity will become I naught by 2. Now can anyone tell me how I have written I naught by 2? Can anyone tell me? Because the angles are different. So I will take all the cos components, and then I will take the average. So the average value that will be coming will be the average of I naught cos square theta. And if students remain remembering the value, average value of cos square theta and sin square theta, that was equals to half, correct? So that's why I can say the intensity that passing from here is equals to I naught by. This is the in general. If the angles are mentioned, then there's no problem. But in general, whenever lights are coming, that means it will become, after polarization, it will become I naught by 2. Let's suppose if theta is given as 90 degree, then what will be happening? Cos 90 is 0. That means intensity will become 0. That means no light is passing from the polarizer because intensity will become 0. Clear? See, three cases are given. Let's understand what are the 3 cases. Angle between polarizer 1 and polarizer 2 is 0. Both are at the same angle. There is no angle of difference. See, here unpolarized light is coming with intensity I naught. Intensity is I naught. Now, and a polarizer is kept. That means all the components will be having some theta angle. So here what will be happening? The light there that will be coming here will be I naught cos square theta. But at all are at some different angles theta. That's why what we will be doing, we will be taking the average. When we will be taking the average, it will become here what you can write. Here you can write it will become I naught cos square theta, and then I will take the average, so it will become half. That means the intensity that I have reached here is I naught by 2. The intensity that I have reached here is I naught by 2. Again I have taken a polarizer. But the angle between them is 0. Angle between them is 0 is again, that means here what it will become, previous intensity into cos square theta. And what I can say about theta? Theta is equal to 0. That means cos theta is equals to 1. That means can I say it will remaining same intensity? And it is very obvious. If a small gate is there and this kind of polarizer amplitude is only allowed to pass, the angle between them is 0. That means if from this is able to pass, that means all the intensity, can I say, is able to pass from the second polarizer also, because the angle between them is 0. अरे एक गेट है जिससे एक ही इंसान एक ही टाइप का इंसान जा रहा है, तो दूसरा गेट जो एग्जैक्टली सेम है उसे भी तो सेम काइंड ऑफ इंसान पास होगा कि नहीं होगा? करेक्ट होगा, ऑब्वियसली. सो दिस इज द फर्स्ट केस. लेट्स कम टू द सेकंड केस. Again, intensity of the incident light is coming is I naught. After first polarization, it will become I naught by 2. I have told you from why it is coming. Now, in the third time, when it is passing from the second polarizer, the angle will be 90 degree. If the angle will be 90 degree, cos of 90 will become 0. That means not a single, because it is perpendicular. If it is perpendicular, not a single component will be able to pass from the polarizer 2. That means intensity will become 0, or in the other ways you can say that there is no light that is passing. Correct? Come to the next one. Angle between P1 and P2 is, let's suppose, some angle theta. Again, what we will be doing it if it is in general, after first it is very clear, after polarizer 1 the intensity is equals to I naught by 2. That means after polarizer 2 it will become I naught by 2 just multiplied by cos square theta. This will be the in general result. Is that clear? Easy thing. A single equation you have to remember. For example, let's have a question so that better understanding will be there. See what the question is saying. Unpolarized light with intensity I naught is passed through a polarizer and then through a second polarizer filter with an angle of 30 degree relative to the first one. What is the final intensity of the light? Very easy question. After first polarization, what is the intensity that I have told you? It will always become, see, here some light is coming. After coming here, intensity will become I naught by 2. Correct? And this polarizer it is an angle of 30 degree. That means after, let's suppose this is I1 and here let's suppose intensity is I2 and I have to calculate intensity I2. So I can write I2 I can write previous one, that is I1 into cos square theta. So what is I1 you have got I naught by 2 into cos square 30. What is cos of 30? It is equals to root 3 by 2, that means 3 by 4 into I naught by 2, that means it can be said 3 I naught by 8. 3 I naught by 8. Which option is coming correct? 3 I naught by 8 option A is correct. Is it clear how to get understand the Malus law? This is the variety of question from where that you will be having. Correct? I hope that it will be clear to you. Basic question, nothing special. See, the example that I was telling you about, that this person is wearing a glass, and what he is saying, the sunlight which is an unpolarized light after passing through the polarites of sunglasses become polarized and the intensity of the sunlight coming to the eyes decreases, and that's why our eyes feels cool. Why our eyes feels cool? Because when the sun rays are passing from our specs, the intensity will become half in the first time only. So to decrease the intensity, we always use polarized sunglasses. That is the, if you're going at some shop, please ask them, sir, give me the polarized glasses, so that sun intensity will become decreased. Okay. Now, second way of polarization, there is polarization way by using some crystals also that you study from NCERT. Polarization by reflection. This is also a numerical part, and that's why I need to tell you. What happens when unpolarized light is falling, it will perform two phenomena. One is reflection, second one is reflection. So this reflection will be unpolarized, there is no polarization, but the reflection part is partially polarized. And at what angle it will be completely polarized? It is called as Brevister's angle. The angle at which it will be polarized is called as what? Brevister's angle. Let's see what is that Brevister's angle. Brewster was also a scientist who have calculated some specific angle for which the light, incident light, was becoming polarized. So let's see about that. The degree of polarization or reflected light depends upon the angle of incidence. Okay. See here what is the scene. I will tell you completely. This is the normal. This is incident run. Incident 1. The requirement, the condition for this should be the angle between the reflected and the refracted ray should be 90 degree. This is the basic requirement for getting the reflected ray as completely polarized light. For a particular angle of incidence IP, reflected light will be completely polarized, and the angle should be between them will be 90 degree. Now let's see the calculation, how the calculations goes. This will be what? Can you say this is nothing but I reflection, angle of reflection is equal to angle of reflection, and I can say this, let's suppose, as R, angle of refraction. What I can say here is, what you can say, you can write IP plus R plus 90 is equals to 180. Correct? The sum of this complete straight line will be 180. Correct now? So from here, what you can write for R can be written as 90 minus of IP. 90 minus of IP. Correct? We got one relation. Now apply Snell's law at this surface, and let's suppose the medium is mu. क्या लिखोगे? And it is coming from air. One sign, if it is a different medium, not given air, so you have to change. That's why this derivation will also become important. Thank you, Saurav. Thank you so much. See, the incident ray that is coming here, you have to check that if it is air or not. This derivation that I am telling you is for air, so be careful whenever you are applying into the questions. You have to be very careful. That's why I will say that go from the complete basics. It will hardly take a minute. Just apply Snell's law. What you'll be writing: 1 into sine of I ip is equals to n times mu into sine of r. What is the angle of reflection? I can say r. And what I can write for r, I have one from equation 1 I have already derived. It is nothing but I am writing 90 minus of I, and here already I have sine of I, correct? So now what I will get from here? Can I say sine of 90 minus I will become cos of I, and here it is what? Sine of I. Now take this cos I here in denominator, it will become tan of I is equals to mu, or angle, or this angle is represented as IB, that is Brevister's angle. It is represented as tan inverse mu. This is the formula of Brevister's angle. That angle of incidence is equal to tan inverse mu. Clear? Easy thing. But please remember, again I am warning you, be alert. If it is coming from some different to different medium, this mu that here one I am taking, it will become changing. So according to the situation, you have to adjust your equation. Correct? Very good. So this is the derivation that I have told you. Let's have a basic question and the last question of this topic. Finally, we are going to complete complete optics. Was a major topic that we have finally completed, achieved it. Okay, very nice. Fine. The refractive index of water with respect to air is 4/3. Find IP for air. It is coming from air to water. That is what you'll be saying. Brevister's angle is equals to tan inverse mu. What you can say? Tan inverse. What is the refractive index? It is equals to 4/3. It is IB. That means what you can say? Tan I is equals to 4/3. बताओ कौन से एंगल पे होता है? 53 or 37? It will be sin I divided by cos I. That means it will be 53 degree. That means IB is equal to tan inverse 4/3 is equals to 53 degree. अरे इतना तो आता है ना? Means option C will be the correct answer. Clear? समझ आया? Option C, 53 degree will be the correct answer. So this was all about wave optics. Again, I will say what is the wave optics, very important chapter, most important topic. I will tell you again, YDSC, it is the soul of this chapter. You cannot leave this topic at all. Okay, and this complete chapter, the beauty of this chapter is that it is completely connected. And if you are studying it, understanding it from initially, never you will going to get stuck. If you are understanding all the basics, then any kind of question, even J advanced question also, you will be able to crack. But if you are not understanding the derivations, even the NEET question also, you can get stuck. Because sometimes if a small change will be happening now, number of maximas will be more than the limitations and all these things, you will be getting stuck. Okay, so try to understand from the complete basics. So from next class, we are going to enter into the particle nature, or I will say the combined dual nature, that the debate that we have studied. Now Einstein will be coming, his photoelectric effect will be coming, de Broglie will be coming, and all these things we will be seeing. Planck constant we are going to use a lot. So now we are going to enter into that world and the final portion of class 12 syllabus. So that will be starting from next class. Until next time, keep learning, keep growing with Tapasya, Endigu and Nendigu Nama Tapasya.